Welcome back. This is an Aleks homework video on calculating the pH of a dilute acid solution. So the pH is the negative logarithm of the concentration of hydroniums. So if you can find the concentration of H3O+, then that is the pH. So we're going to recognize that this is a weak acid. Acetic acid is a weak acid. And any weak acid that you put in water is going to partially break apart into hydroniums and then be in equilibrium between hydroniums and acetic acid. So we're going to simply do an ice table. One of those components are going to be the hydroniums. Once we find that, we're going to take the negative logarithm and you'll have your pH. So it's not a terrible problem, but you have to be able to think your way into it. You have to kind of see where you are and know how to get to where someone else. And I guess that is the trick of all chemistry, is knowing where you're going with it. So I've got a balanced equation here where I've got this acetic acid is in water, and it's making hydroniums plus conjugate base. And so I'm just going to make a case of A. This is a case of A, so I've got the hydronium molarity times the conjugate base over the acetic acid. And then they gave me that it was a 2.3, and then they gave me the case of A at the top. So 1.8 times 10 to the negative 5 is my case of A. So this is my whole expression now. Now this is in equilibrium, so I do have to do an ice table. It's not a hard ice table because it's balanced and it's a 1-to-1-to-1, and the acetic acid is going away and my hydronium is being made, so that is my X. So in equilibrium, I've got 2.3 times 10 to the negative 1 minus X, and then X and X. And I'm going to put those values back into the expression to see what I can come up with it. So I've got X squared here, since hydronium and the conjugate is both X, over 2.3 times 10 to the 1 minus X. Now here's where I'm going to fudge a little bit. This is a tiny, tiny value. The case of A is times 10 to the negative 5. There's very, very little product being made. There's very, very little acid being produced in acetic acid. Mostly what you're going to have is the HC3CO2 floating in some water. Because of that, I'm really not needing the PhD in applied mathematics it's going to take to do this. So I'm just going to approximate that that's 0. It's just basically nothing. And if so, all I can do, by the way, this is X squared, is I'm simply going to multiply those two and take the square root of it. And when I do, I get X squared equals 0.0020347. And that is my hydronium concentration. Now I'm just going to take the negative log of it. And they ask for two significant digits? No, 2 decimal places. So 2.69, 2 decimal places, is my pH. So I hope this helps.